So for those of y'all tuning into the lecture, we've been playing with print, followed by the end parameter. What the end parameter means is replace the default character turn that happens when we print and replaces it with something. For example, we print I, and then after the word I is going to appear the word ha, and it's not going to go to the next line. Just like that. So it says I, ha, love. Whereas we would have expected love to be on the next line. And here it says I love My Little Pony, but love is going to be on the same line as I, and My Little Pony is going to be on the same line as love. And why do you do that? Because we don't always want it to go to the next line. If we're going to print a whole list of things, we may not want them listed vertically. We may want to list them horizontally.
So if you wanted to do that to a list.
Yeah, let's do that to a list. List is equal to, numbers are easiest. Inside our blocky braces, 1, 3, 5, 2, 4, 6, 9, 8, 7, whatever. And then for each element, E is going to be my word for element, in the list. That's bad. I was starting to do another syntax. I was starting to do Java or C# there. For E in L, colon, print E, comma, and then we want a space between each one. So end is equal to quote, space, quote. But we do want it to go to the next line at the end of all that business. So just print like that. That's just like hitting enter on the keyboard. It'll go to the next line after it's done printing out that row. This way it should print 1, 3, 5, 2, 4, 6, whatever. Let's go back. Let me just close this and run it again. All right, there we got all the list items horizontally rather than vertically. Is that cool? That makes sense?
Mine actually printed the actual list without, I mean, with the brackets and everything, and it just printed it like 3 or 4 different times.
Let me come look. Right.
So you could do that instead of the \n, but that'd be a lot more work.
You would have to know whether you were at the end of it or not. Exactly. Here I did not need to do \n there at all. That was completely superfluous. Normally you would just do that, you know, and it would have the same effect. Okay, so regarding that if underscore underscore name equals underscore underscore main, if you have a function that you're defining, I'm just going to make a brand new file. So you don't want to do this necessarily, or I'll tell you why not. If underscore underscore name, those are 2, not 3 or more, underscore underscore equals quote underscore underscore main underscore underscore quote colon, then let's call some function. I don't care what the function is called. myF for my function. Now for us to be able to do that, we need my function defined. You could conceivably, and I did get homework that looked like this, define my function right in this code. And it'll work just great. Hello there. And then what I'm going to tell you is to move that definition outside of it. And the reason why is the only reason that we would put this main business down here at all is so that we could import the functions that were in this file into another file. Because that's what this is. This is a gatekeeper, and anything inside of it does not happen when you do the import. Anything outside of it does happen. So this definition doesn't happen when we do an import of this file into another one. So we're essentially importing an empty file.
Oh, so it just goes to the end and not at the beginning.
Right, so we just want to stick that there, like that. And then we'll be good.
Oh, so anything you do, so it's got to go to the end.
Right, right. And typically what I do is I make a main function. Define main, colon, and then, you know, whatever's supposed to be in here. And then call that from down here.
Oh,
And then-
that's what you call it, okay.
Yeah.
So, basically, I got cut.
And the primary motivation for doing that is because you're going to use a lot of other languages where main is the name of the function that is invoked by the operating system or by, you know, by the runtime engine when you run it. So you talk about the main method or the main function. We can have main methods, main functions here too. We just need to set up the call for them like that.
Oh, so, not cool right now, are
All right, so we were looking at iterations. And we've actually gone about far enough that we could consider this Unit 1.
Are you recording?
I am, sir. Thank you very much. Very good to suspect that I'm not, because I wasn't earlier.
And it's not muted.
It is not muted. I also checked that. There we go. We have our audio slider. I hope all is well. It's as good as I can get it right now. So, what I've done in my other classes is I've said, it looks like we've done enough for Unit 1. Everybody get out your pencils. It's time for the exam. And then I said, just kidding. And then people threw books at me. So I'm not going to do that with you.
I was gonna say, because I don't got a pencil.
I didn't bring a pencil. You can't make me do it. All right. So, but why don't we go ahead and plan on having the exam next Wednesday if all of y'all can be here. Can you be here?
Yes.
I think there's a different time listed in the syllabus, but if we can all agree to be here on Wednesday, we don't have to abide by that. And the reason for that is just to cut it off before we, you know, start stuffing too much knowledge in our brains. The exam will be open book, open notes, open Google and typing in search queries. It's open everything except sending chat messages or email to someone asking for help. Instead, just ask me for help, and I'll come help you. So don't stress about it. On Monday, we'll do a review of what's coming up on it, just so you know. And it's just going to cover pretty much everything we have covered. The best review would be to go and look at our note files out in content, such that they are. There aren't a huge number of them, but there are some. Also, to look over, just look at the stuff that we did in the in-class assignments and the homework assignments, and then review the text up to chapter. What chapter are we on? I believe 5. And then you'll be good. So we talked about, I believe, loops and loops with break statements. Did we talk about the continue keyword?
Yes.
All right. What does the continue keyword do?
Let's see if I can remember.
Well, what does break do? Break's the easy one.
It breaks. Stops.
Kills the loop, gets you out of the loop. Continue is like a break, except instead of exiting the loop, it runs back up to the top and repeats it again without doing whatever was underneath the continue. So you could write something like this. For x in range 10, colon, print x, and then if x equals 10, nope, let's do it at 5. If x equals 5, colon, break. And then I'm going to just tack a done down here at the bottom, untabbed. I'm going to call this Feb 22B, real creative name, Feb 22B. And so it just prints out 1, 2, 3, 4, 5. That's all it does. That's kind of dumb. Why didn't we just make it for x in range 5 if we want to do that? But it illustrates the idea.
Was it supposed to print out 0?
Yeah, it was, and if I said 1, that was my mistake. It did start at 0. When you do range, it starts at 0 and goes up to but not including the larger number. So 10, 0 to 9. is what it's trying to do. However, when it hits 5, it breaks out of the loop. So let's play with continue. We're going to put a continue statement in here so that it only prints out odd numbers. We're going to say if x modulus 2 equals 0, or equals 0, then continue. Put that above the print statement. If x modulus 2 equals 0, colon, continue. So what that does is it says if it's an even number, don't print it. Don't check for this break. Don't do none of that stuff. So if it's 0, it's going to continue. It's not going to print anything. If it's 1, it goes ahead and prints it. If it's 2, it gets here and it continues. Goes back up to the 4 without doing anything else. So it doesn't print. If it's 3, that doesn't stop it. So it prints it. So it's going to print 1, 3, and then 5, and then still break at 5. I'm going to change my comment. Prints 1, 3, and 5, and stops. So why do you care? Well, you could write an input function where you got some input, and if it was invalid, you could tell the user that, and then you could just issue a continue and make it run back up to the top and force the issue. Ask them again. Something like this. While true, with a capital T, colon, n is equal to input, what is your name? Now we're going to pretend that in this universe, all names are 2 or more letters long. So, if the length of n is less than 2, colon, we're going to give them an error message. Print names must be 2 or more characters. And then continue. Now we need something to get us out of the loop. But whatever goes down here, print your name is, comma, name. It's just going to do that over and over and over until we get really tired of it. So why don't we do a check? Oops, it's not name, it's n. Excuse me. If n equals, stop. Or let's make it actually the word break, colon, then break. That way we have a way out of the loop.
But the continue won't run it back into the if statement. It'll run it back to the top.
Right, continue works with the first while above it.
Even if it's nested? Or
Well, if you nest a couple of them like this, while A, and then you do while B, and then you have continue, it's going to run up, this continue would run up to that one. And then if there was a continue down here that wasn't nested, it would run up here to that one. So it looks for the while one of which it is a body.
okay.
Here's the body of that while. Here's the body of that while. All right, let's run this and see if it actually works. What is your name? My name is K. Names must be 2 or more characters. What is your name? I don't know. Your name is I don't know. What is your name? Break. Okay. Your name is Break. Alrighty. So that was kind of dumb. We should have reversed the order of this so that it didn't print your name is until after we did that. We could cut that line, put it down here. Anyways, what you're seeing is some form of input validation. Not as sophisticated as that try and accept stuff we were doing. What that try and accept stuff did is if they typed in something and it caused an exception, like if we wanted a number but they typed in a string, then the accept clause would catch it. This doesn't handle that. But it does handle whatever arbitrary condition we want to put here that we can check for. And there are lots of things we can check for, really. Let's go look at the string methods that are available to us to play with. I believe I uploaded into our notes. It's possible I did not. I'm not seeing them there. Well, I'm pretty sure I put it in the homework. Alright, I need to unlock this so that y'all can see it. Alright, if you refresh, folder number 6 is available to you. There's something appended to the end of the file that I actually meant to also upload as notes and put in the notes folder, and I didn't. So just open it, refresh, and open the PDF or the Word doc, and you'll see this thing. This is methods for testing strings. These are all the different things, well, not all of them, that you can do to a string. You could call isAlnum. What does alnum mean? Alphanumeric or it means a character, a letter, or a number. Al standing for alpha, like alphabet. The only problem was that it doesn't work with decimal points. If you called isAlnum and the number in the string you were searching was 3.14, it would give you an error. But let's play with it. Go back to your thing and just launch the shell again, Python shell. And make a string, s is equal to 1, 2, 3. And then do s.isAlnum, like that. And that's true. That's because it is all letters or digits. Let's change s. S is equal to 1, 2, 3 dot 4. And then s dot is alnum, parentheses. False. It's no longer all letters and numbers. There's also one just for letters, and there's also one just for numbers. Let's go look to see what those might be. Is alpha returns true if the string is all letters and it contains at least one character. If you try to do these things on an empty string, it returns false. Is digit returns true if the string S consists only of digits and is one character in the length. Is lower, if it's all lowercase letters, it returns true. Is space returns true if it's all white space, either tab keys or spaces or /n's. And is upper, the opposite of is lower. Now Python's funny in that you can do this. You can call these methods straight on a constant like that. 1, 2, 3 dot is alpha, parentheses in parentheses. Are you going to do that in your code? Probably not. It's just a real quick way of demonstrating dot is alpha, rather than doing s is equal to 1, 2, 3 and then calling s dot is alpha. I'm not going to do that very often. Let's put a name in there. S is equal to Fred. S dot is alpha. Should that return true or false? It's going to be true because it's all characters. S is equal, now let's do S is equal, S dot is digit. That'll be false because there's no numbers in it. What if it said 1 Fred? S equals to 1 Fred. And then we do S dot is digit. Well, we've got a number in it, so is it going to print true or false? No, because is digit wants the whole thing to be numbers. False.
So what's the difference between is digit and is a no? Number.
This this looks like is a num, but this is actually is al num, which means alphabet or number. Alphanumeric. So this, if we do s dot is alpha al numeric, that's going to be true because these Fred 1 is all digits or numbers. Does that make sense?
Yeah.
Yay. It's a mix of is alpha and is digit. So examples of string comparisons. John equals John. True enough. We know how to use the double equal signs. And just a warning, and when you go on to take Java, you can't compare strings with two equal signs. You can compare numbers, but not strings.
Can you compare? You can't compare strings, period, in Java.
Yeah, you can. You just can't use two equal signs. Right, right. You got to do something funkier. So here, John equals John. That returns false. Why?
No capital.
Yep, one's capitalized, one's not. They don't match exactly. Is John with a lowercase j less than John with an uppercase j? Well, you just have to know that in the character set, capital letters appear before lowercase letters. What I would have done is I would have done A or ABC is less than, JKY, and then that would have been true because A's come before J's in the list. So you can sort data if you have to by using less thans. And if it's a string, then it just does an alphabet order, and uppercase letters are considered smaller than lowercase letters, which is backwards of what you might think. But if you want to know the order in which they occur, you look up an ASCII chart. Just go to Google, find an ASCII chart, doesn't matter which one, and you can see that, for example, all the uppercase letters, which start at value 65 going all the way down to 90, are considered smaller than all the lowercase letters. Because an uppercase A has a value of 65 and a lowercase a has a value of 97. So if you do if uppercase A less than lowercase a, that would be true. But if you did vice versa, if lowercase a less than uppercase a, it'd be false.
So delete is the highest value?
Apparently. How do you put that in a string? I don't know. Actually, I do know. You could embed that as a character. ASCII was invented a long time ago, and it's got things in it that nobody uses anymore, like this stuff. Start of heading, start of text, end of transmission. None of that gets used. However, the tab still does get used. /n still gets used. That's a carriage return. That's about it. And then you skip all this, the escape key.
Cancel.
Then you get all the way up to the real stuff starts at 32.
Space.
So you could use this kind of stuff, for example, to do a password validator. And I think we did that in 1113. We may do it again in this class as well. And how do you do that? You just count the number of uppercase letters. You count the number of lowercase letters, so on. And then you make it follow the rules, which always seem to be at least 8 characters in length, must contain both uppercase and lowercase letters, must contain at least one digit, and must contain at least one special symbol. And then it argues with you about which symbols you're allowed, depending on which system you're doing this for.
No, wrong.
Okay, so there are homework assignments sitting there. This one's kind of like that other one, in which case it's all just typing. However, one of them says, I don't care, don't bother typing this in. And I'll show you that one right off the bat. Yeah. If you have that PDF or the Word doc open, you'll see that on one of the pages is a file called Earthquake. And what it does is it says Richter is equal to float input enter a magnitude on the Richter scale. And then it does, if Richter is greater than 8, print most structures fall. If Richter greater than 7, many buildings destroyed. If Richter is greater than 6, print many buildings considerably damaged, some collapse. L if Richter is greater than 4.5, you say you live in Oklahoma and there's fracking nearby. Else, no destruction of buildings. Okay, why do I say you don't have to type this in? Because it's real clear what it's doing, right? You know what ifs and elifs do, and you know what print statements do. You're not going to learn anything by typing this one in, but I do want you to look at it. There's a couple of others. This one demonstrates comparisons of numbers in strings. We have two integers, 2 and 4. If 2 times 2 is equal to 4, we print 2 times 2 is equal to 4. So using double equals is great that way. Comparing floating point numbers. X is equal to the square root of 2, and y is equal to 2. Let's just go play with this for a brief second. Pop open your shell again. Close it and open it again if you want. And then do this. We're going to have to import the math library.
Are we doing the shell?
I meant to do the shell. I goofed on that. Import math. A is equal to SQRT for square root of 2. Ew, I goofed. What did I do wrong? Oh, math dot square root. Thank you.
If you import it, why do you still have to call it?
I could have done this. From math import square root, and then that statement would have worked.
That's the thing I was
Square root of 2 is 1.414.
So anyways, I'm just going to do the import math again, and then do A is equal to math dot SQRT of 2. And then do B is equal to A times A. And then print B. Now you would have thought that the square root of 2 times the square root of 2 would equal 2. But floating point math, multiplication and division, has errors in it. I shouldn't say errors, it's just got rounding problems. Because you cannot store the square root of 2 exactly using binary. It does an approximation of it. Accurate out to like 16 decimal places, but it's still an approximation. And so when you multiply it back against itself, you get this little business. If you have two numbers and you want to see if they match, it wouldn't be good enough to do this. If B is equal to 2, colon, print, yep, and then backspace. It didn't print yep.
because it's not. It's 2 point.
Right, because they're not. So if you're comparing two floating point numbers, you have to be a little bit more clever.
Now, if you rounded that B,
You could round it. That's one approach. Or you simply take the difference and see if the difference is smaller than what you call epsilon, an acceptable range of errors. And so let's do that in our code. Let's go back to maybe, doesn't matter which one, Feb 22b. And we'll do that. A is equal to 2.2. Excuse me. Still need to do that import math. Import math. We should do this up at the top because it's always going to be asking us for our name stuff. I'm cutting that and I'm pasting up this up at the very top. Import math. A is equal to math dot square root of 2. B is equal to A times A. Here's the statement that's not going to work. If B is equal to 2, colon, print, perfect match. That's not going to work. We're not going to get it to print perfect match. But we need to see if they're close enough. And you're right, round would work. You could round both of them out to like 5 decimal places. If you don't have a language or a command that rounds that easily, then you'd probably want to follow the technique that I'm just about to show you, which is take the absolute value of the difference between those values. Then, if that difference is less than a minimum, which some textbooks called epsilon, which you get to define. Can I spell epsilon? Epsilon. Then it's close enough. So we're going to compare B and a number. I don't want to hard code the number 2 in there. I'm going to do C is equal to 2. I should have done that to begin with. And then let's get the difference of them. Difference is equal to math.abs of B minus C. And if the difference is smaller than our margin of error, 0.1 is going to be our epsilon, then print close enough. Oh, and it blows up. Let me guess, absolute value is not a math function. I did not need to precede it with math. Okay. Alrighty. So take out that math dot in front of the ABS. Not math.abs. Alright, so when you run that, it won't say perfect match, but it will say close enough. It would be interesting to write some kind of loop where we did this check for the square root of 1, the square root of 2, the square root of 3, to find out which ones are perfect matches and which ones aren't. But nah. You might want to modularize this a little bit by putting this in a function. And then you could just call that over and over to see if two values are close enough. Really, 0.1 may not be precise enough. You might want to say, you know, there. Even now, it's going to say close enough. Because B, which we never printed, but we did when we had it open as a shell, is really very precise. It's got 1, 2, probably about 15 decimal places in front of it. So one of the homework assignments demonstrates that. And another one covers the idea of nested ifs, which I believe we did for conditionals. Nested if statements are when you have, like this. If something is true, do something. If something is whatever, then come over here and do something else. You know, it's where you have an if that is already indented. Just like nested while loops, or when you have a while and it's already indented because you're inside somebody else's code. And I'm trying to think of a real quick example of that. Let's go up to all the way to the top in front of import math. And we'll do input, age is equal to float, parentheses, input, parentheses, what is your age? Now we're going to do some nested ifs. I forgot to put a second close parentheses, so it was giving me grief. All right. So first we're going to rule out totally bad input. If your age is less than 0, it's going to yell at you. You don't need the parentheses. That was my mistake in typing it. If age is less than 0, print. No way, dude. else, colon. Now we can put another if statement. If age is less than or equal to 17, colon, print, stay in school. Else, colon, print, get a job. Apparently we're not allowed to go to college in this universe. Okay, that's a nested if. How do you know it's nested? Well, it's tabbed over.
Right.
It doesn't matter whether this tabbed over if is part of that if or there. It's still considered a nested if. You know, doesn't matter whether this second one was over here or over here. You know, same idea. It could be nested under the else clause. You can nest as many as you want, but the logic starts to get a little freaky. If you like and have 4 or 5 or 6 levels of indentation, there's probably another way that you need to solve it. Could we have done this in another way? Yeah, sure. We could have just used elifs. Right, right. No particular reason in this case to have implemented it in the way we did, but it works. Typically what you want to do is you want to rule out a bad situation, an error situation at the beginning, and then you have a chunk of code which may have other ifs inside it. And that may be appropriate to not have an elif, you know, because there may be some additional calculations you need to do here. We are all super clear on and or? Question mark? We don't need a lecture on that anymore? Good deal. Okay, here's one. This program computes income taxes using a simplified text schedule. It's got 2 rates. Rate 1 is 10, rate 2 is 25%. The rate 1 single limit is 32,000, the rate 1 married limit is 64,000. So we ask them, please enter your income, and then please enter S for single or M for married. This has got some nested ifs. It's conceivable you could do this with if, elif, but you would wind up using ands and ors in there. And the way this is written, it doesn't use ands and ors. So if the marital status is S, then we come down here. Income, if income is less than that, then you tax them at that rate. But then, unfortunately, if it's larger than the single limit, then you add some more tax onto it. Same thing for married. If marital status is not S, it comes down here and it checks, is your income less than the maximum for a married person? If so, great, you only pay a little bit of tax. Otherwise, you pay a lot of tax. Here's another one that uses nested ifs. You know what I ought to do is instead of making you type these in would be to make you revise these so that they don't use nested ifs, because each one that they've shown us so far could be done with if, elifs. But the clauses would have to use ands, probably, in order to get that to be done. All right, this one looks long, but it demonstrates something that we haven't really talked about yet. The end function, and the count function, and the find function, and starts with and ends with. Those are pretty self-explanatory, and I meant to put a table here with those, but I didn't. But let's look. If you say if A in B, that returns true if it finds A and B, but it better match exactly. And this notation works both for lists and for strings. So we could do this. Go back to your shell. Python shell. If Vader in Darth Vader, colon, print. How do you spell what he breathes? Heavy breathing. There we go. And then backspace all the way out. Okay, it's true. Vader was in Darth Vader. However, if I didn't get the case right, if I had uppercase V there, then it wouldn't have found it. Let's set our name equal to Darth Vader. Name is equal to Darth Vader. Let me make sure I get this absolutely right so I don't have to check. Okay. If, let's just do name dot starts or begins with a D, lowercase d. I did name, not in. Yeah. In dot begins with lowercase d. Still not right. Okay, for Pete's sake. I knew I was going to get it wrong. Starts with no uppercase letters. Okay. In dot starts with no uppercase letters, lowercase d. It's true. Darth Vader did begin with a lowercase d. How about ends with? In dot ends with lowercase d. That's going to say false because it doesn't end in a lowercase d. It ends in a lowercase r.
What is starts with no capital?
Yeah, starts with no caps. Yep. My mistake. I apologize for that. I slipped into Java mode again. I want to check something. L is equal to 1, comma 2, comma 3. You don't have to type this, but then I want to see L dot starts with 1.
That's not capital L.
Yeah, thank you. L. Yeah, I didn't think so. Okay.
It only works for strings.
Only works for string.
Right. Whereas the in function, if something in something, that works with lists as well as strings. It actually works with every data type. In Python, there's not only lists, there's something called dictionaries, and there's something called sets. We'll learn about those as well. Alrighty. Going back to iteration, I believe that's where we were. Oh, let's eyeball the other homework assignment. So for that one, I just want you to type them in and take a screenshot. And you know how to upload, give me a screenshot, right? If you're using a PC, you hit print screen, and then you open Word or WordPad, and you hit Control V or paste or whatever, and it puts it in there. So just put in like 4 screenshots showing the program running. Then the next one is a program called House Cost Calculator. Let me remove.
Oh, so you rather have a screenshot than actual code?
Yeah, for this one, I just want to see that it ran. I mean, everybody's going to be typing in the exact same code, so I'm not going to get much benefit out of looking at the code. All right, the house cost calculator. Design a program that prompts a user for data about a house being built. We're going to ask them for the number of bedrooms, the number of bathrooms, and the number of cars the garage holds. Then we calculate the price of the home, which is a $50,000 base price, plus $20,000 for each bedroom, plus $10,000 for each bathroom, plus $5,000 for each car the garage holds. And here's an idea of what the output could look like. Welcome to the house cost calculator. How many bedrooms do you want? 2. How many bathrooms? 3. Why would you have more bathrooms than bedrooms? I don't know. How many cars should the garage hold? 2. And then we just print out a little itemized list. Your house will cost 2 bedrooms equals $40,000. 3 bathrooms equals 30, 2 cars in a garage is equal to 15, base cost of 50, and then adds it all up, it might actually equal what I wrote there. I didn't add them up in my head, so I said I can't guarantee the above math works. So, please make the program handle bad input. Remember how we did on the pay program where if they typed in garbage, we said, nah, and just assigned a value. If they type in bad input, just assume 1 bedroom, or just assume 1 bathroom, or just assume 1 car. So this calculation should not be very difficult. Anybody want me to walk through how you would want to do that? Because I could, but if it instantly clicks, yeah, how I'm going to do that. That's my question.
For the try and accept, for the accept, that's where you write in what you want it to fill.
Right. That's where you say you entered bad data, assuming 1 bathroom or whatever.
So why they choose accept instead of like assume?
That's what they're called, exceptions.
Oh,
It's an exceptional case.
gotcha.
Other languages have a different way of writing it. Very good question. They will block off what you're trying to do with a try statement. Try, and print 1 divided by 0. That's going to blow up because you can't divide a number by integer 0. And then there's something called a catch down here, where you catch the exception. And then based on what that exception is, you could try to handle it or whatever.
Doesn't JavaScript have catch?
I bet it does. Java certainly does. So catch, or print, oops, you divided by 0 and the universe ended. So there we go. That's how you do it in other languages. Python, for some reason, didn't just use the word catch. They just use the word accept instead. So this makes sense. To calculate 2 bedrooms, you're just going to do, cost of bedrooms is equal to the number of bedrooms times the price per bedroom. Same thing, cost of bathrooms is equal to the number of bathrooms times the price per bathroom. Cost of garage is equal to the number of cars times the price per car. And then the total is equal to everything added up. So this one actually requires you to think on your own, whereas the other one is just typing in code like a robot. So.
I'll be looking at not Java but JavaScript a little bit for my friend he did his capstone JavaScript.
So when you use a for statement to step through a loop, that is called a definite loop. I'm not going to ask that. But a while statement is an indefinite loop. It just simply loops until a condition becomes false. Whereas in this language, a for loop is a definite loop because it's going to be stepping through a series of items.
So even making a while loop that does the same exact thing as a for loop, it's still...
It's just considered an indefinite loop. Yeah. It's, there's some blurring between the concepts. Yeah, the question was if you do a while loop that does the same thing as the for loop, is it an indefinite loop? And it's just that the while loop is considered an indefinite loop word, whereas for in this language is not. In a lot of languages, the for loop is also an indefinite loop, but there's another structure called for each, which is a definite loop. So the syntax of our for, you define your list, and then for variable name in list, print, and then you use that data. That one has to match that one, and what you were doing was putting
print
that
the
one.
whole- So it would say Happy New Year, Joseph, Glenn, Sally, like
right,
every
yeah,
time.
and it would print it 3 times. So this is an awfully nice way of doing it for friend and friends, but I can guarantee that if you follow that syntax, you're going to wind up putting S's in the wrong places.
Yep.
Just saying. It's a good way to do it. So loop patterns. Generally, if you're using a while loop, or even a for loop, you initialize some data before the loop starts. Now that's not true with my while true loops. But I'm a weirdo. I introduce you to while true loops, and then the textbooks never talk about them. Performing some computation on each item in the loop, possibly changing the variables in the body of the loop. If it's a definite loop, you won't be changing the variables in the loop that you're stepping through, but you'll be doing something with them. And then looking at the resulting variable when the loop completes. For example, you could ask for a series of numbers, and then you could print out the average of the numbers. So the initializing the list is when you're adding data to the list, and then you're going to have another loop that steps through, performs a computation on each item in the loop, and then you're going to do your final calculation, calculate the average by the length of the loop, and printing it out. So counting and summing loops. We've done that. Count is equal to 0. Actually, I think I just did sum. I don't think I did count. But the same idea. You set count equal to 0, and then each time you find an item in it, you add 1 to count.
Yeah, you did it with total when we were trying to.
Exactly. I did total plus equals or whatever. Here we're just adding 1 to it. If we were calculating the total, we would add itervar to it each time. And they show that here. Total is equal to 0. The syntax of the for loop header is exactly the same for itervar in our list. But then we do total is equal to total plus itervar rather than count equals count plus 1. How many times do you write a counting loop? Not very often, because you have that len function. You can get the length of the list that way. But to be honest, you can get the list, the sum of a loop with the sum function anyways, but I make you write your own sum code anyways.
Can you go back to that one up there? Sorry.
Which one, the count or the total?
The count. I guess I'm confused on how that's gonna. It's not gonna print out the list or anything in the list, is it?
No, it doesn't print anything in the list. It's just a calculator for it determines the length of the list. It initializes a counter to 0. For every element in the list, count gets increased by 1, and then we print that value out. You could put some specialized condition. If you were trying to count the number of even numbers, you would have an if statement here. If, let's do that one. Let's do that one. This will be about the last thing we do today. So, I'm tired of putting it all in the same thing. Let's create one more file. List is equal to, and then just type in some numbers. 1, 3, 100, 2, 6, 9, 88, whatever. And then count how many even numbers are in the list. Now that's something you couldn't do with the len function. So we really do have to use a loop. So we need to initialize a counter variable. Count is equal to 0. And then for every element in the list, there I go with my Java syntax. For every e in list, and I'm saying the word every, but it's not there. For e in L, colon, if e%2 equals 0, that means if you divide it by 2 and you don't get any remainder, that means it's an even number, and we want to increment the count. Count plus equals 1, or count equals count plus 1. Then let's print the list, and then let's print how many evens were found. Evens found, colon, comma, count. I'm going to save this one as even counter.
You can't define anything. Well, I guess you can't. Like, you couldn't define the list. I know you said not to use the word define, but I forgot what you said substituted with. Like how you have for E and L, But you couldn't do like for E and L and then make the list right there.
Well, you could copy those values into another list if you wanted to. We could make a list of only the even numbers. That'd be pretty cool. Let's do that down here. Let's make a empty list called evens. Evens is equal to square braces with nothing there. And then for E N L colon, same idea. If E%2 is equal to 0 colon, add that onto our list.
E dot of pen, or no,
Evens
dot of pen.
equals evens plus E, or evens plus equals E. And then let's get down here and we're going to print out the evens. Oh, can't. Can only concatenate a list.
That's what.
I should have used something else. I should have probably used, I'm going to forget whether it's add or append. It's append, thanks.
Yeah.
There we go. That'll do it. That'll create a list of only even numbers based on our input there. I'm not sure if that addressed exactly what you were asking.
Oh, I was saying like if you had like you see where you have for E and L,
Right.
and you have like your colon. But I was saying if you had for E and L equals, and then you made your list right there, you know, is what I was saying. Like you can do that. You just couldn't make a list on the fly. Like
There's a weird syntax you can use where you could probably condense this down to a single line of code. But I'm not ready to try to wrestle with that yet. So no, you really kind of want to break it up like that. You want to set up your loop, and then you want to use your loop value.
oh,
You
so-
could put a list right there.
Yeah, that's what I meant.
Oh, that's what you're asking? Yeah.
But you couldn't set.
1, 3, 5, 2, 4, 6, like that.
Yeah,
Sure, you could do that.
but you couldn't do L equals that list.
No, you can't
Yeah.
combine them. You can't say like that.
That's why. That's what I was asking. I was like,
Yeah.
you can't just make a list on the fly like that.
Right.
Okay.
You either define your list, yeah, you need to initialize your list beforehand. And you had the point that I tell you not to use the word define, and that's just because in this language you don't predefine your variables. You don't say int a is equal to 1 and double D is equal to 3.3. That's a definition. You define a as being an integer. You define double as being D. But you can say initialize, you know. Initialize a to 1. Initialize D to that. Yeah, yeah. So that's a good term.
Okay.
All right, guys, let's make a Dropbox for this. If you look on the due dates of the Dropbox, they're pretty generous. March 7, March 12. On Monday, we'll do a review of everything we've covered so far, along with whatever new lecture we feel like doing. And then on Wednesday, we'll do the exam. And like I said, don't stress about it. Those of y'all who've had me before know that my exams are not a big boot in the face.
No, tell me they're hard for study. Tell me they're not hard at all.
Man, they're brutal. Study hard.
There you go. Perfect. Now
Yeah.
I'm ready.
Perfect.
Oh. This is gonna be hard.
You know that coding website? We're not doing it. Like, if I wanted to just go ahead and do everything in that.
Yeah, that's really good practice. I haven't told.
We're not going to do any more in it within this class.
Oh, we could.
Well,
I hadn't specified that yet. But there is a really good site. Now that you mention it, let me finish making that Dropbox.
I'm sorry if I keep sidetracking.
No, 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 no. I just have attention deficit. Here we go.
Yeah, Mr. Rabbit Hole.
What?
Rabbit Hole.
All right, I is there now.
There's a hole in there.
If you're looking for practice with Python,
I-
one good place is it's called Code. You would think it would be Code Academy, but you leave the A off, so it's just Code Academy.
Oh, yeah,
untitled.com. And last semester it was missing the Python tutorial, so I didn't assign it to us. Otherwise I do for the beginning, for the 1113 course. That's a really good thing to step through if you haven't already done so for a previous class. Do the first 2 lessons. It's review, and you'll go, yeah, and you'll get done with it in an hour, but it's still good. Then there are other places, but I haven't found another tutorial place that I want to assign yet. All right, guys, see you Monday.
February Seago. Oh, there it is. There. Oh, because I
Chill.
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 Yeah.